In this class, we are going to have to do a little work with the derivatives. Now, please do not panic. We only need derivatives to calculate two things, marginal revenue and marginal costs. Let's get started. Here is a basic definition of derivative. Derivative is a measure of how a function changes as its input changes. Again, do not panic. For example, remember the demand function we learned in the previous chapter? Let's assume the quantity demanded, or Q, is equal to 2 minus price, or P. So, as price changes, so does quantity demanded. The derivative is measuring how fast or how slow Q is changing when P, the price, changes. That's it. We are concerned with how fast or how slow something is changing. That is what a derivative does for us. That is why we need it. How fast or how slow something is changing is more technically referred to as rate of change. Now, how is the derivative written? This is called its notation. Let's take a look. The derivative of y with respective to x is written as dy over dx, or dy by dx, or dy over dx. For example, the demand function q equal to 2 minus p we just used in the last slide. The derivative of q with respective to p is written as dq over dp. Right now, I'm going to show you the rules for how a derivative is calculated. Keep in mind that what I'm about to show you is for reference. When we start calculating MR and MC, which are marginal revenue and marginal cost, we will return to these rules to guide us. If this seems confusing now, it will make sense when we start using it. So what are the rules for calculating a derivative? Let's take a look. We are going to check 5 cases. The first one, remember that a derivative is dy over dx. So in some case, the y will be a constant. It's just a number. Here I have y equal to k, where k is a constant. Since derivative measures rate of change, but y is a constant, so there is no change. So the derivative of y equals to 0. So the rule is for any constant functions, the derivative of y equals 0. 0 means no change. For example, if y equal to 25, then dy over dx, the derivative of y equal to 0. In our future work with the MR and MC, the marginal revenue and the marginal cost, we will have some exponential functions. So we need to know how to handle this. Look here. Y is equal to x raised to the power of n. N can be any integer. N is exponent. So when this happens, the derivative of y, or dy over dx, is equal to n times x raised to the power of n minus 1. Or, for example here, if y equal to x raised to the power of 4, then dy of dx is 4 times x raised to the power of 3, n minus 1, 3. Another kind of exponent we will say is y equal to c times x raised to the power of n. As we see here, what is c? C is a constant number. That is expressed by dy over dx equal to c times n times x raised to the power of n minus 1. So for example, if we try to find out the derivative of the function y equal to 3 times x raised to the power of 2. That is y equal to 3 times x squared. Then dy over dx will be 3 times 2 times x raised to the power of n minus 1, that is 2 minus 1, that is 1. So we get 6x. So we just mentioned when y equal to c times x raised to the power of n, then derivative of y will be c times n times x raised to the power of n minus 1. But what if y equal to the c times x? Again, c is a constant number. Then the derivative of y, dy over dx, will be c. For example, go to 2x, then derivative of y dy over dx will be 2. If y equal to 25x, then dy over dx will be 25. Why? How did we get this? Here we use a piece of the math knowledge, that is x raised to the power of 0 will be 1. Let's say y equal to cx. So y equal to cx. Here the power of n is 1. So c derivative of the y will be c times the power 1, then times x raised to the power of n minus 1. Well, here n is 1, so 1 minus 1 is 0. So that equal to the c times 1 times 1 equal to c. That's how we get when y equal to 2x. Its derivative of it is 2. And if y equal to 25x, derivative of it is 25. If y equal to 100x, then derivative of y is 100. Here is the last rule. We're gonna put all the rules we learned in the last slide together. The rule is the derivative of sum of two functions is the sum of derivatives of the two functions. So if we get a function which consists of two functions, then we find out the derivative of each one first. Here we find out the derivative of 3x first, then we find out the derivative of the 2x squared, then we add them up. So derivative of 3x, based on what we learned from the last slide, it is 3. And the derivative of 2 times x squared is 2 times 2 is 4, and n minus 1, right here n is 2, so 2 minus 1 is 1, so we get the 4x. Okay, that's it. Again, do not panic if this is overwhelming. These are simple tools that we will use to calculate marginal revenue and marginal cost. It will make more sense as we start using them. There are 4 questions in the homework, and I'm going to walk you through the first 3 questions. Then you only need to do the last one to see if you completely understand it. Let me know if you have any questions.